Thank you so much for being here. I'm very excited to talk to you about how to build a scalable continuous integration for iOS. I'm Alberto. I'm a software engineer from Italy. I'm based in London. And for the past 10 years, I've been an individual contributor at justeattakeaway.com. I've done all sorts of things around iOS, and in more recent years, I shifted my attention to the fantastic world of DevOps. I'll try to get you excited about this world. So if you don't know the company, justeattakeaway.com is a leading food delivery business. We operate in 19 countries. We have more than 700,000 restaurants on our platform. And of course, we are present also in the United Kingdom. So what this talk is about. So we're going to try to implement a continuous integration infrastructure in-house. A few months ago, I wrote a blog post with the title, Scalable Continuous Integration for iOS. I think it was well received by the community. Maybe it can be a little tricky, complicated for Swift engineers. So it summarizes the current status, the current setup of CI at justeattakeaway.com, right? But a bit of history here. So we went through several steps, right, to iterate on our CI to get to where we are now. As I said, I joined the company 10 years ago, and the CI that we have today, definitely it's not the CI that we had at that time. At that time, the team was just 3 engineers. We had no idea about DevOps or CI, on pipelines, etc. So we just relied on an external tool. And then at some point, someone in the company said, oh, you cannot use that. You need to do everything in-house because we are big enough, right? OK, fine. So we tried to come up with something. At first, we started using TeamCity because other teams were using TeamCity. Then eventually, we started using Jenkins, but Jenkins was owned by another team. Then eventually, we got a hold of Jenkins, tried to understand more how it worked. We moved our Mac Minis from where they were to a server room. And then the pandemic hit. So we started taking the Mac Minis at home, because if there is a power cut in the office, we are left without CI. That was fun. So we thought, OK, let's migrate to the cloud. So several steps, right, to get where we are now. And that made me realize that, yeah, it's difficult, really, to build a career in software engineering without being exposed to certain DevOps things and CI and more processes. So the agenda for today is, what is a continuous integration and continuous delivery system? We're going to go through some existing CI/CD solutions. But we're going to focus specifically on one setup, the one that we use in my company, which is based on AWS EC2 and GitHub Actions. We're going to implement this setup using some cool DevOps tools, and we're going to go through some final considerations. So what is this CI/CD thing? If I can give a definition, I would say it's a system that executes tasks on your code to allow the integration and the deployment of software continuously, if you're lucky. I'm going to get back to this in a second. But let's make a bit of a distinction here between continuous integration and continuous delivery. Continuous integration is about making sure that the changes proposed are safe to be merged in the default branch. This is where you would run your unit test, UI test, snapshot test. You would collect the code coverage. You will run the linters with lint. Maybe you're going to generate some artifacts. While the continuous delivery part is about deploying the software so that it can be used either internally or externally, right? So this is where you would use Fastlane maybe to build, archive, and upload the IPA to the distribution channels like Firebase and App Store Connect. So if we try to visualize it, we can imagine our developers, our engineers committing code to the source control system, like GitHub. And eventually, a pull request will be raised. And the server part of the system will catch that and say, OK, I'm going to execute some tasks. So the server has the knowledge of the pipelines. And the pipelines are a list of steps to execute. So there will be a scheduler component there in the server that is going to say, OK, I'm going to dispatch the tasks to the different workers. And the workers are different machines. And they will go on and perform these tasks. So in the case of continuous integration, maybe we're going to generate some logs, some screenshots, and we're going to upload them to another service like S3, an Artifactory. In the case of distribution of delivery, continuous delivery, maybe we're going to upload it to Firebase and App Store. And earlier, I was saying we are going to do this thing continuously if we're lucky, because on iOS, there is really no such thing as continuous delivery. We need to wait for Apple to approve our build. So we're not like the web team that can deploy multiple times per day. When the workers complete their job, they report back to the server component via feedback service, and then eventually the developers will see the status check on the pull request, green or not, and they will understand what went wrong, and they can proceed from there. So having a system like that in place that works well is absolutely fundamental for DevOps methodologies, so that we can code, we can build, we can test, and release our software. So let's go through some existing solutions. There are some solutions that give you both parts, both the server and the workers. There are some that only give you the server. Maybe the solution will be more customizable, more complex. And there are other solutions that just give you the workers, okay, just the machines for running the tasks. But at the end of the day, you need both to have a working system. One thing to note is that the workers absolutely have to be Apple hardware. So this is where you're going to have your Mac Minis or Mac Pros. But the server doesn't have to be, and it rarely is, an Apple machine, and it is usually a Linux machine. So some existing solutions in the market, like the amazing CodeMagic, which is a sponsor, are like this, right? So they are ready to be used out of the box. You just pay a price, and you have a full service for your CI/CD system. The workers, in almost all the cases, are virtualized, and with this comes a performance hit, right? It's not like running unit test on CI on your local machine that they go pretty fast, but if the worker is virtualized, you can see that CI is taking more time. These services also provide usually some other products like dependency caching or things like that. So it's not just about the server and workers. And I would say that Xcode Cloud is a special snowflake, because if you use Xcode Cloud, you absolutely are going to use both the server and the workers from Apple. While for the other systems, maybe you can use just the servers and attach your workers to that. But, and I would say that they are absolutely appropriate for small to mid-size apps, maybe some scale more. But when things get really complex, maybe you want to consider other solutions. Maybe you work at Facebook, at Google, where Bach and Bazel are used. Or like in my case, you've been exposed to the first one there that I'm not going to mention. I will. So studies have shown that the main cause for burnout in the workplace is Jenkins. Okay. So they are powerful and flexible build system, absolutely. But they come with more complexity, and they require a high degree of customization. And then there are other solutions in the market, on-premise, it would be that you just have your hardware on-premise or cloud-hosted, right? And this is just for the workers part. So if we talk for a moment about on-premise, that is a very ugly picture. That was the server room that we had a few years ago, before the pandemic. And when you manage infrastructure, in your server room, you have to take care of power supply, you have to take care of the updates. It's really difficult to have the same setup on every Mac Mini. You can try to use Ansible, if you know the tool, to try to replicate the environments, but it doesn't allow for recreating the operating system from scratch. So it's not great. It comes with a lot of maintenance pain. every time that you want to update also Xcode, for example. So if we move to the other side of the spectrum, we can talk about Mac Stadium, right, which is probably the most famous company that provides so much hardware, Apple hardware. They have an entire huge data center in Atlanta with thousands of Mac Mini, thousands of Mac Pros. And of course, when you have that much hardware, you can provide all sorts of services. Or you can just rent Mac Minis and Mac Pros to do whatever you want. Or you can use their Orca solutions, which is absolutely brilliant. Orca stands for Orchestration with Kubernetes on Apple. Kubernetes is an orchestration solution to orchestrate machines. And what they've basically done, they have Dockerized macOS, or to be more precise, they've put the Docker controls around macOS so that they can manage all the Mac Minis or Mac Pros via Kubernetes. But if we look at something between these two solutions, we can see that we're still in the cloud, and we can use AWS, which is what we're going to use today. AWS is the only cloud provider, and when I talk about cloud providers, I mean AWS pretty much, Google Cloud Platform, and Microsoft Azure, that give you the ability to use macOS instances. So what they've done there, they bought a bunch of Mac Minis. It was back in 2020. They attached them to their Nitro card that allows users to use the Mac Mini in their EC2 platform. And EC2 is the virtualization service from AWS. And the way it works is just use EC2 from the console or CLI, however you want. And usually, 99.9% of the cases, you're going to use Linux and Windows on these machines. So from their very powerful machines, let's say Linux machines, you can ask to just get a single slice with the CPU that you want, with the memory that you want, and just use that. But for macOS, you really cannot get a slice, a virtual slice. You get the entire Mac Mini. So once you rent a Mac Mini, it's going to be yours for 24 hours, and you pay by the hour. So we can try to, let's go. We're going to focus, as I said, more on the workers part, because, we're going to leave out the server. The server, in this case, is GitHub Actions. Some of you might be already familiar with how to craft pipelines in YAML files in GitHub Actions, which is an amazing product, very well documented. But we're going to focus more on the workers. And before starting, actually, a little bit of a distinction between ClickOps and infrastructure as code. So in ClickOps, you would just go on a dashboard, in this case, AWS, and you point and click in the UI. So this is very error-prone. You cannot replicate the same process easily. You will have to document it. But it is surely intuitive, and we're going to start this way. Then we're going to move to infrastructure as code. And it is more predictable, more reviewable, more auditable, and replicable, right? So whatever we have done, we would do in ClickOps by going in the UI and clicking, all of that, we can turn it into code so that it can be in Git. OK, so we go to AWS. All right, we're going to log in. And then we go to the EC2 sections. Okay, in EC2, the first thing that we need to do is go in the dedicated host section, because we want to allocate the dedicated host, which is the Mac Mini, right? So there is a way to specify this, the instance family and the instance type, which is basically just a way for AWS to categorize the different offering of images, of dedicated host. So it's Mac 2 and Mac 2 Metal. Mac 2 Metal, in this case, is M1, so M1 Apple Silicon. And once we have it, it's going to be there, available, and it's ready for us to be used. Then we're going to move to the instances sections, and we're going to allocate an instance. So now we just have the Mac Mini for us, but we need to install software on it, right? And the way we do it is by filling a bunch of fields, right? So first we give it a name. Then the most important thing is probably the AMI, so that stands for Amazon Machine Image. It's pretty much the sequence of bytes that you want to be on disk, right? So the software pre-installed, and Amazon provides you with the operating systems from Apple. So in this case, we're going to go for Ventura. I know, a couple of years ago. And then we're going to select the instance type, which is the same instance type of the dedicated host that we pre-selected. And then we're going to set some key pairs, right? Because once the instance is up and running, we need to enter the instance over SSH, and we need an SSH key, right? So we create a key pair here. Once you do, it gets downloaded on your downloads folder to be used later. And then another bit of setup is about the security groups. So security groups are pretty much the virtual firewall. You can decide what traffic comes in, what traffic goes out. And because we have a key pair, an SSH key, we need to open port 2022, right? Port 22. And then as a last bit, we can decide how much storage we want to give to this instance. Once we do this, we go through a summary, click OK, and then the instance is going to be up and running in no time, just a few minutes. Now we have the SSH key. We can open a terminal, connect to the IP address of this instance, and once you're in, you can run a VNC session. You're going to see the UI of the instance. You can log in as you would normally do. You can install Xcode or whatever software you need. And once you've done that, you actually have to connect this instance to the server, right, to GitHub Actions. And it's very easy if you use GitHub Actions because you would just go to the settings of the repositories. In the runners sections, there will be some code here that you just copy-paste pretty much. We don't have to go through it. And once you run it, it's going to download the app, the GitHub Actions runner app, and it's going to connect the workers to the server, to GitHub Actions. And you have your precious runner there in the idle state, waiting to be used, right? So now we've done this work once, and we have one instance up. But what if we want to replicate it, right? We're still in the console. We can create an image out of it, right? So we're going to have our AMI, Amazon Machine Image, with our software installed on top of the version that Amazon gave us. So we can create an image here so that in a few minutes it's going to be available, and then we can use this one as a starting point to create the second and the third machine. But we want to do this better, right? We want to do it with IAC, with infrastructure as code. So it's time to introduce a couple of tools that will simplify our lives. So the first one is Packer. It's a tool from HashiCorp. HashiCorp is an amazing company that provides tools for DevOps. It's a CLI tool and is a machine image creator, right? So we're going to create the AMI using Packer. And then the second tool is Terraform. And we're going to use Terraform to deploy the infrastructure and deploy the AMI that we have created with Packer. All right? So we're going to see some code. It's not Swift, but shouldn't be too scary. So we're going to define 3 variables, just a simple example. One is the macOS version, one is the Xcode version, and the third one is the password of the user, of the main user on the machine, the EC2 user, right? And then we have some code that is pretty much saying to Packer, OK, go on AWS, create the instance, find the AMI with the macOS version that I gave you, run it, and then execute some steps that are defined after this. And at the end of it, export the AMI so that we can deploy it later. And the steps, just the very basic steps for the example here are, the first one, we want to set the password for the user on the machine, which is always good to do, right? Then we want to install Xcode, and that's why we defined a variable earlier, because it depends on the version of Xcode that you want to install. And then we're going to put the code that we've seen earlier from the settings of the repository. We're just going to copy it over and put it there, right, to connect the runner to GitHub Actions. Packer is a CLI tool, so you can just run it from the command line, and you pass the 3 inputs that are the 3 variables. And once that's done, Packer is going to run, and then at the end of it, you're going to find an AMI with an ID that it can be used later by Terraform. And now we move to Terraform, right? similar story. We define one variable in this case, and it's the interesting bit, I would say, because this is the thing that will make our infrastructure scalable, right? Is the fleet size, so the number of instances that you want. So we leave the variable there, and then we start defining in code all the little settings that you've seen in the dashboard earlier, right? So the SSH key, the key pair, we're going to define some resources, and Terraform will treat these resources as things to create in code in AWS. So the AWS key pair, that's the name of the resource. And of course, when you do this in the console, the SSH key is downloaded in your downloads folder, right? But when you run a CLI tool, you don't get that. So we need to find a way to get this SSH key and store it somewhere so that we can retrieve it later. And we do that with Secrets Manager, which is another tool. Then we move on to the security groups, right? So we define a security group to allow traffic on port 22. And that's what we're going to do here as well. That for egress traffic, for traffic that is leaving the instance, we allow everything. Maybe not super secure, but that's OK for now. And then we're going to define an AMI, right? But I'm using the word data here. So I was using resource until now because I'm instructing Terraform to create stuff for me. But for the AMI, I'm not telling Terraform to create an AMI. I'm saying the AMI is there. Packer created for me earlier. Just use it. Right? So this is a reference to the AMI with Xcode version and the macOS version that I previously decided. And then the final bit, we are going to run our instance, deploy our instance, AWS instance. And we're going to use the security group, the instance type, Mac2Metal, what else, the SSH key, and crucially, the variable fleet size. So Terraform will respect that. And if the number here is 5, Terraform will create 5 instances for us in just one click, right? So we can run Terraform this way, Terraform apply, and we pass the variable, very similar to what we did with Packer. And if we run this, yeah, it's going to create a security group, SSH key, everything, and one instance, because fleet size is 1. But Terraform is very good at maintaining state. So if you run this command multiple times, Terraform is going to say, OK, you already have this, right? The state hasn't changed. But if you run this command with 5 or any other number, Terraform is going to migrate the state, right? So it's going to say, oh, you had 1, you want 5, I'm going to add 4 extra instances for you. So you get scaling very, very easily for the entire infrastructure. And then, of course, you can run Terraform destroy when you want to destroy everything, so you don't leave SSH keys in AWS, so you don't incur any extra cost, and the whole thing will be destroyed. One thing that we haven't covered, though, is the allocation of the Mac minis. So the first step in ClickOps, so we went to the AWS console, and we rented a Mac mini, explicit action. We didn't do it in Terraform. You can do it in Terraform. It's quite complicated, I would say. But given that the Mac minis are the resources that really cost a lot, you might want to have better control, or at least that's what I thought it was worth doing, right? So we can use the AWS CLI to allocate the host with just a bunch of parameters, and then we can release the host when we think that they're not needed anymore. OK, so we went through quite a lot, but it's not over, right? There's a lot more. So to connect the instances to GitHub, you need a join token. And to get a join token, you need a personal access token or an enterprise token. And you don't store the token in the AMI for obvious security reasons, right? So you store the token in Secrets Manager, which is another service for AWS. And then, of course, you need to give some permissions to the instance to reach out to Secrets Manager to get the token. And you do that via IAM, which is Identity and Access Management, right? And then you need to find a way to pass the ID of this token that is in Secrets Manager to the EC2 instance. And you usually do it via the user data when you run the instance the first time. And in order to do that, you need to use another tool from AWS EC2 and macOS init that handles the different startup operations, because macOS is different from Linux. So once you start playing with this thing, you see that they are all connected, and you start learning more and more about the cloud. So to recap, we started by allocating in AWS manually a Mac Mini. Then we ran an EC2 instance on top of it. Then we SSH'd into the instance to install Xcode and whatever other software. And then we exported the AMI to be reused later. And then we did it in infrastructure as code. So we did the opposite. We started from the AMI. We told Packer, OK, this is the setup. Create an AMI with a version of Xcode, macOS that I want. Create the AMI for me. And then with Terraform, we deployed the AMI to have our own infrastructure on the dedicated host that we had previously allocated using the AWS CLI. And this allowed us to have scaling, right? Because with a single invocation of the tool, we could scale to a number of instances. These runners are connected to GitHub Actions, and from this moment on, in your pipelines, in your workflows, in GitHub Actions, you can set the runs on label with the labels that you have specified, and they're ready to go. They're ready to be used. But now it's inception level 2, right? So we want to try to deploy our CI/CD runners using a CI/CD solution, GitHub Actions. So you can create pipelines in GitHub Actions for the things that you want to automate. And in this case, are 3, right? So the first one is the creation of the AMI. Second one is the deployment and the decommission of the infrastructure. And the third one is the allocation and the release of the dedicated host. So for the first one, you can map the configuration of Packer into a workflow like that. So the variables that we've seen before become input in GitHub Actions. So you can specify the macOS version, Xcode, or Ruby, or whatever else. So the moment that Xcode 16.1 comes out, you can just go on GitHub Action, click a button, wait, and you have your AMI ready that you can deploy, again, with another workflow in GitHub Actions to run Terraform with a specific AMI ID that has been created in the previous step, and then you can specify the number of instances. And you can also allocate and deallocate the host via GitHub Actions. So some final considerations. There are many ways to take it further from here. You could decide to automate the scaling, right? AWS allows you to scale very easily with the auto-scaling groups. That usually works well with Linux. When it comes to macOS, it's a lot trickier, I will have to say. But you can come up with some smart scaling, I would call it. For instance, during the weekend, technically, you don't work. So there's no reason to have the macOS instances that are expensive running for no reason. So you might create the entire infrastructure every Monday morning, and on Friday evening, you destroy it completely, right? Which is smart scaling. Then you can consider doing CloudWatch monitoring, which is another tool in AWS, so that you can monitor the instances. And if, for instance, no pun intended, for instance, one instance starts misbehaving or you're running out of memory, the disk is full, you get some alerts in CloudWatch, and you can debug or take it forward from there. Or you can decide that, oh, I love IAC, I love infrastructure as code, I want to create everything in IAC now. So if you're not on GitHub Actions, you are on other things, maybe Jenkins. You might think, OK, I'm going to implement the configuration, the deployment of Jenkins with infrastructure as code. That's absolutely possible. We did it. That was difficult. And then, of course, optimize your code and your pipelines, because there's no point in having an amazing infrastructure on bare metal hardware that goes very fast and is very performant, but your code is not, or maybe your pipelines takes too long and your UI test take like 40 minutes to run. What's the point, right? So always optimize your code, right? Never forget about that. If we try to do some back of the envelope calculations, right, to compare more or less some solutions, if we want to have 5 Apple Silicon M1 instances on Orca, Well, I think I got it right. That's pretty much the price. Maybe other solutions like Anka, they provide the AMI ready for AWS, cost a bit less. If you implement it in-house, you reduce costs further. And if you do some smart scaling, you reduce cost a lot further. Of course, if you have your Mac Minis in the server room, that's probably the cheapest solution, right? But of course, well, it's a very different game there. Also, Mac Minis are assets, so the company will incur into capital expenditure. So you have to consider amortized cost and depreciation of the asset, while if you go on the cloud, is operational expenditure, and usually a finance team prefer operational expenditure. But maintenance paying is going to be absolutely high with Mac Minis in-house. It's very much none with solutions like Orca. And I would say it's very, the satisfaction is high if you implement it in-house and it works. So this setup, after all, the one that I presented, we've used it at justeattakeaway.com for a couple of years now, and it works really well. So I would like to conclude by saying that there is no size that fits all, right? So I'm not here to tell you, oh, go AWS, absolutely, it's amazing, go the cloud. It really depends. It depends on various factors. If you are a one-man band and you're just working on your simple app and you're your side project, maybe you don't even need CI at all, right? Maybe you have your test, that'd be good, but you don't need CI to run them, right? Or maybe you want CI, but you ran out of the free tier for the solutions that you're using. So you might consider implementing some dev-hosted runner. So you connect your machine to GitHub Actions to run things. That's an option, right? Depends on the code base size, on how many apps and tools and repositories you have in your company. What is the expected workload, right? How many pull requests and CD jobs you have per hour, right? That will inform decisions like this. Or if you have already some in-house hardware, maybe you just join the platform team or whatever team that takes care of this, and the previous team lead just bought a bunch of Mac Minis. That's not the moment to move to the cloud. You're just gonna use that, right? Or, the usual question, buy versus build. Do you want to go for a full third-party platform, or you just want to get a platform that gives you the workers and you have the server in-house? There is a DevOps tool, a DevOps team already exists at your company. They can help you and they can share knowledge on how to set up this thing. That's a thing to look into. Are there any budget restrictions? What is the number of teams that you will be able to serve with this solution written in-house? Anybody in your mobile team that is interested in learning more about DevOps or learning more about the cloud and be exposed to this kind of stuff, right? That's a great way to skill up, I would say. Or would virtualization help? We didn't touch on virtualization today, but there are all sorts of dedicated tools to have virtual machines within the same host, the same Mac Mini or Mac Pro. The virtualization tool, virtualization framework from Apple that allows you to have two Mac instances, two Mac environments, Mac OS environments in the same host. There's something to look into that as well. So that, I think, is all I have for you today. That's it. Thank you very much.